Okay, we're gonna give this a try so you can actually see me now too as I do this. And you'll know what a weirdo I look like. So fundamentals of Python, we're going on to the next thing. We just completed a big project doing our receipt maker. And so we want to do a few other things. Here we go. So first thing I want to do is give you a pop quiz. Does this work? Why or why not? So I'm going to not say anything for a little bit and let you sort of think through this and discuss with yourself. Do these two lines of code work? Why do they work or why do they not work? And we're going to test them out and see if they work or not. So think about that. I'll drink my Diet Dr. Pepper slowly while you think. Have some ideas? Okay. Well, why don't we try this out? I'm going to pop over here into Visual Code and put that over there. And I want to show you this. You might be seeing this every time, this Visual Code editing involved, all this welcome screen. If you don't want this coming up every time, just unclick that. It won't come up, and you can just close it. I probably had unclicked that a while ago. That's why you weren't seeing it in any of my videos. But now I'm on a different computer, and I hadn't unclicked it yet, so you could see it. Okay, so let's try out that code we were just doing. As I mentioned, I'm on a different computer, so you don't see my other files here. But we're going to go ahead and start a new file. And actually, I just made a mistake. I don't know if you noticed. Started a file inside of my Vemb. I don't actually want to do that. But if I just close that, it goes away. I can select up here, make a file there. That's the file I wanted. And let's do our test.py. This file is not going to live long, but we can start it and see what it looks like. And you'll notice I don't have my terminal up. So let's go ahead and get that running. Come up here, click on terminal, go to new terminal. And my virtual environment is activated. And you can see the computer and login name are a little bit different here. All right, so if you remember that code said something like this. It said print. It was printing an F string. And then it was taking the variable element. And it was saying, is my favorite sport. And then we were setting element equal to football. Now, you might be yelling at me from home, and if you are, great, because in the slide, I actually had element capitalized. So if you caught that as the reason this wasn't going to work, you're right. That's one reason this isn't going to work. But that's actually not the reason I was hoping you would catch. So let's go ahead and make that lowercase and see, is that the difference maker? Okay, let's find out. Python 3 run test.py. That is not the only issue. And we probably could have told that without running it because right here we have element underlined in that orange color and it tells us it's not defined. This is actually an order issue. In some cases, order is going to matter in our coding. Basically, we want to make sure that if we're going to use a variable like element, we declare the variable element before we use it. Okay. So if we switch those two things around, our yellow squiggly goes away. We can pop back down here, run it again. Football is my favorite sport. Works perfectly. Okay. So just a little quick test to see if you remember how these things work and to show you that order matters in some cases. You're going to learn later that while order still matters, some pieces are going to appear out of order, but we're actually going to use them in order, which is going to be an important differentiator. Okay, so that was that. Let's jump back into our slideshow here. Good, we all passed our pop quiz. All right, now let's talk about input. I don't have my guessing game file here, but if you remember to our guessing game, we had to get input from our user. And then we actually stored that input in a variable. And actually, if you're paying attention, you've noticed I made another mistake here. I've left a capital U. I'm going to go ahead and blame this on Google Slides. I bet Google Slides is capitalizing the beginning of my statements here without me prompting it to do so. Let's jump back into our code. We can continue using this Python file. And let's play around with user input a little bit. First of all, let's just do a print statement, and let's go ahead and get some input. And if you remember, if we open up our parentheses here, we can see the docstring, what's called the docstring. And the docstring is information about how this print function works. So this print function takes a prompt and it returns, we've got this little arrow symbol here, it returns a string. str is short for string. The type in Python is actually called str, but it's a string. The data type is a string. So if we're going to use this prompt, let's go ahead and say, hey, user, type something. And let's see what this does, okay? So let's go ahead and jump down here. Let's run our code again. Football is my favorite sport. Prompt, type something. I'm going to go ahead and drag this up a little bit so it's a little bit easier to see. Okay, let's type something. I'm going to type hi, and you'll notice it goes ahead and prints it out. So it takes my input and prints it out immediately. That's what this line is telling it to do. I am going to check if I can't zoom this in just a little bit. There we go. There we go. Make it a little bit larger, and I'm going to go ahead and move my head over here a little bit so it's out of the way. Okay, so we can print our input right away. We can also store our input. So user input. In this case, we are naming a variable user input, and we are going to assign it using the assignment operator. The information that is being returned from our input function, where we send in a prompt. This time, I'm going to use one of those extra special characters of a new line. Okay, 1 second. Hold on 1 second. Hold on 1 second. Hold on 1 second. Okay, quick pause. All right, so we can also store our user input, right? So let's go ahead and run this. Type something, spits it out. Type something else, okay? Something else, and now something else is stored in the variable user input. You might also be interested in like what type of information you're getting back from user input. If you remember from our guessing game, we actually had to take another step to turn the number that our user was putting in into an actual number in terms of Python, into that data type. Let's take a look at some information around our data types. So if you remember, here are our major data types: integer, float, Boolean, string. And I think I've mentioned before, what input sends back to us is a string, but we don't always want a string. Sometimes we want to change things around. First off, let's go ahead and find out, prove to ourselves that we are actually getting back a string. So we're going to say print the type of thing that user input is. So this is a neat little function that is built into Python that actually will print out what type of object this is. I'm going to take out this stuff for right now so that when we run our program, it just is a little bit cleaner. I'm going to clear up my console here without the caps lock on. Okay. And let's go ahead and run our test py. Type something else. Okay. I'm going to type something else. And you'll notice I get back class string, class str. str being Python term for string. So it's telling me that this is a string. To show you that this works for other types too, let's print another type. Let's print what type 9 is. Let's print what type. I told you about this being a little bit different, right? Even though it equates mathematically to 9, it's going to be different. And let's also print what type true is. Not squiggly brackets. We just want parentheses. There we go. So we'll print all those out. Something else. And we have a string. We knew that, right? We tried that before. We have an integer. And look, there I show you 9.0 is actually printing out as something different. It's printing out as a float. okay? And then finally, true is printing out as a bool, which is short for Boolean. So there you have our types, right? Our data types. And as I said in our guessing game program, sometimes we want to convert, right, between one and the other. So let's change our user input for a second. Let's ask our user to type some number. And what we're going to do here is we're going to take that number as input, see what type it is, and then change it to a number and see what type that is after we change it. And let's go ahead and print out both before we change it and after we change it. So we'll print the user input before we change it, and then after we will also print it after it's been changed, or we'll change it and print it once we change it. So here we are printing the original one. We are printing the type of it. We are printing the type of it once we change it. And then we are printing it. Actually, let's fix the order of this just so it makes a little bit more sense. I'm going to put this down here. So we're printing the user input, printing the type of the user input. I'm going to go ahead and put a new line. We're going to print a new line just to break up the information in our console, look a little nicer. And then we're going to print the integer version of the input, and we're going to print what type it is. Okay. So it asked me to type some number. I'm going to put the number 9, and you'll notice it spits out 9, and then it spits out the type that 9 is. In this case, 9 is of class string. Then it changes it to an integer and prints out 9 again. Looks exactly the same, but in this case, it's class integer. Okay, so we changed the class of the value by passing it through this int function. And what this int function is it's actually a constructor. It will construct, it'll create an integer based on input. In this case, the input is a string. The string is 9, but it can do it with other things too. And we can do not just integers. We could also theoretically do it to a float. And it would be interesting to see. Let's see how this changes all of what we just did. Let's go ahead and after we do the user input, I'm going to go ahead and clear the screen. If you remember how we did this from Guessing Game, we needed to import the package OS. And then when we wanted to clear the screen, which I'm going to do right after we take the input, we did os.system, and we passed it a command. If you're on a PC, you're going to do CLS. We did clear, and that should just clean things up a little bit for us. So we're going to run it again, type some number. I'm going to type 4, and we get 4 is a string. 4.0 is a float. And I want to draw your attention to the fact that we changed this into a float. And if you remember, floats are always decimals. Even if it's not a decimal, numerically speaking, it's always a decimal type. So it's always going to have that floating point decimal. That's what that's called, having that decimal point in it. So that in that way, we can go to numbers. We can also go to Booleans if we wanted to, by using the shortened term bool. Importantly, let's go ahead and have it type true or false and see what happens. So I'm going to type false. And something interesting happened here, and I'm wondering if you caught it. It prints out false. It prints out its type is string. Then it changes to true when we turn it into a Boolean. I'll talk more about that later, but in part, it has to do with the fact that conversion from a string to a Boolean is not as straightforward as it is for things like numbers, and there can be some wonky mistakes. I want to run our code again, and I want to do a test. What happens if we capitalize false? Okay, we still end up with true. I'm surprised about that, actually. I thought we would end up with false that time, but no, we end up with true. And I'll explain more about that later. I think right now is probably not the time to do that. But be aware of that. If you're converting from a string to a Boolean, even if the Boolean is true or is false, if that's the word put in there, it's not going to convert the same way. I bet you I can get it to, there we go. I can get it to print false. That time, if you weren't, I'll do it slowly this time. I'm actually not going to enter anything. I'm just going to leave it blank and hit enter. When it converts the blank this time to a bool, it converts it to false. So anyway, I'm sort of teasing something we can talk about later about truthy and falsy values when you're doing conversion. But I wanted to show you how you can convert from one type to another, how we can test the type using the type function, and using the constructors convert between types. One last thing I want to show you, if you noticed, I didn't try putting in something that wasn't a number and then converting it to a number, which can actually cause some errors. So let's go ahead and try that now. Let's encourage our, and by the way, changing this prompt is not functionally changing anything code-wise, it's just what it looks like, but let's practice, right? So let's ask our user to type some number again. And then we're going to change it to an integer, doing all the same thing we did before. And this time I want to type something that isn't an integer and see what happens. So I'm going to type the word go. Notice now we get an error. Why do we get an error? Because go does not translate into any integer. And so the integer constructor, int, doesn't know what to do with it, and so it produces an error. We can actually do what's called handle or catch those errors when they happen by using a try statement. So if we'd say try, instead of just do, right, what we were doing before, if we say try instead to do this, let me click down here and make sure we indent, because try, like anything else, creates a code block that we have to indent for. And then it's telling us, hey, try except there's going to be at least one except clause. And the except clause is essentially, okay, try to do this, and when you can't do that, do this other thing instead. And we can print a statement to our user, something that's like, hey, that wasn't a valid number. Okay, something like that. So now we're actually doing something called handling the error, which is something you want to do when you're doing software development. If we don't handle errors, we end up with these things, essentially this crashing of our script. We don't want our script to crash. We don't want our programs to crash. So we have to use some sort of error handling. So let's go ahead and run it. First, let's test the scenario where we've done the right thing. Perfect. We entered 10, class string, turns it to an integer, no problem. Let's run it again, and this time, let's give it something that is not a number, like the word hi. And notice that instead of crashing, we now get, hey, that wasn't a valid number. But the script continues normally, no problem, and we don't have that crashing issue. So that's a great way to handle errors, is to use the try and except block anytime you're going to run into errors. And you don't know always when you're going to run into errors. You'll get used to that. The more development you do, the more practice you have. You'll get used to, when am I going to run into errors, when would try make some sense to use instead of crashing the program. So you'll get used to that, and there'll be times when you're going to want to use that and not use that. You notice when we're printing user input, we don't do anything because that's never going to crash. We don't need to try there, right? So anyway, that's something you'll get used to, but it's a good practice to get into, is handling your errors. I should say not always, though. Sometimes if there's going to be an error, you want your script to crash. You don't want to handle that error, because there should never be an error in that place. And if there is, it means we've done something wrong programmatically that we have to correct. So sometimes errors, like we've talked about before, can really help us in our development of our script. But when there is the possibility with user input to produce an error based on the user input, then we probably want to handle those errors, because we can't always be sure there aren't going to be errors. It's not on us, it's on the user in that case. All right, great. On to the next thing.